Hello students, I am Rajneesh Kumar, working as an assistant professor in NIT Pharmacy Institute, Greater Noida. Here again to discuss some more topics on pharmaceutical organic chemistry. Second, the subject code is BP301T. So, it is a subject of third semester of AKTU B.Pharm courses. Okay. So, the topic of today's lecture is effect of substituents on reactivity and orientation of monosubstituted benzene. Okay. So, we have talked on reactivity of benzene ring when a substitution are already present on the benzene ring in the previous lecture. तो इफेक्ट ऑफ सब्स्टिट्यूएंट ऑन द रिएक्टिविटी हम डिस्कस कर चुके हैं पिछले लेक्चर में, है ना. इन दिस लेक्चर विल फोकस ऑन द ओरिएंटेशन इफेक्ट ऑफ सब्स्टिट्यूएंट ऑन द ओरिएंटेशन ऑन द ऑफ मोनोसब्स्टिट्यूटेड बेंजीन. ओके, इस पे हम डिस्कस करेंगे. सो विदाउट वेस्टिंग एनी टाइम आई जस्ट स्टार्ट माय लेक्चर. सो लास्ट लेक्चर में हम लोग बात किए थे कि देयर आर मेनली थ्री फोर्सेस or three mechanisms which is involved to influence reactivity or orientation of the benzene rings of the monosubstituted benzene rings for the upcoming electrophiles for electrophilic substitution reaction. Okay. Three mechanisms which involves resonance, hyperconjugation and inductive effects. Okay. So, when a substituted benzene undergoes an electrophilic substitution reaction, the substituents already present on the benzene ring determine the location of new substitute. Okay. तो हमने कहा था लास्ट टाइम मीन्स दो तरह के ग्रुप होते थे, एक्टिवेटिंग ग्रुप एंड डीएक्टिवेटिंग ग्रुप्स. एक्टिवेटिंग ग्रुप्स आर ऑलवेज ऑर्थो पैराडायरेक्टिंग, मतलब ग्रुप विच कैन एक्टिवेट द बेंजीन रिंग्स, मीन्स they can increase the electron density on the benzene ring, always direct the coming electrophile on the ortho and para position. While the second category of the group, which is deactivating groups, means the group which deactivate the benzene ring by withdrawing the electron from the benzene ring, will always direct the upcoming electrophile on the meta position. Okay. Third type of group is also possible, which mainly includes halogens. They are deactivating group, but they are ortho para-directing. So, there are exceptions are there. Okay. There are exceptions, halogens are exceptions. Okay. So, three types of groups are possible. Now, we can say that all activating substituents and the weakly deactivating halogens are ortho para director, and all the substituents that are more deactivating than the halogens are meta director. In short, we can say that. Okay. Thus, the substitution can be divided into three groups, as I told you. First is ortho para directing or activating group, second meta directing or deactivating group, and third is halogens, which are deactivating but ortho para directing. And reactivity, we have discussed that reactivity was influenced because of the electron withdrawing or electron donating. Okay. So, electron density will get increase or decrease on the benzene ring. So, overall the reactivity of benzene ring will increase or decrease for the coming second electrophile, while the orientation or the location of the coming electrophile, second electrophile on the benzene ring will be directed by stability of carbocation, which is formed in between the reaction, electrophilic substitution reaction. Okay. We all know that electrophilic substitution reaction will takes place in two steps. In the first, formation of sigma complex or adenine ions or carbocations will occurred. In the second step, hydrogen will get abstract from the benzene. So, just see the slide. Here we are having here we are having mono substituted benzene. Okay. And the second electrophile approach that substituted benzene for attack, we are getting we can get three types of isomer: ortho isomer, meta isomers, or para isomers. So, which isomer will be formed as a major product? It will depend on the substituents which is already present. Okay. इस पे डिपेंड करेगा. Because of that substituents, the intermediate carbocation which is formed in the second electrophilic attack will show different stability, and that stability describes the next location of the second electrophile on the benzene ring. Okay. So, now if a substituent donate electron inductively, अगर कोई ऐसा substituent benzene ring के प्रेजेंट है जो इंडक्टिव इफेक्ट के थ्रू इलेक्ट्रॉन डोनेट कर रहा है, फॉर एग्जांपल एनी अल्काइल ग्रुप, फॉर एग्जांपल मिथाइल ग्रुप है ना, अल्काइल ग्रुप की बात कर लेते हैं तो मिथाइल ग्रुप आ जाता है. तो वी आर टेकिंग द एग्जांपल ऑफ टोल्वीन. तो टोल्वीन है, मतलब मिथाइल ग्रुप इज प्रेजेंट एज ए सब्स्टिट्यूएंट ऑन द बेंजीन रिंग, एंड दिस टोल्वीन इज नाउ गोइंग फॉर फर्दर इलेक्ट्रोफिलिक अटैक, electrophilic reactions, electrophilic substitution reaction. So, we have three options. The coming electrophile can go on ortho position, it can also go on meta position, and it can also go on para position. So, where it will attack and what we will get as a major product, which isomer, ortho, para or meta. So, very simple, we just check that in which position we are getting more stable carbocation. Okay. In which position we are getting more stable carbocation. So, let us see. Suppose this electrophile Y plus, they will attack on ortho position. We are getting this carbocation, areninium ion. This areninium ion will show resonance. Sorry, this areninium ion or carbocation will show resonance. So, total 3 resonating structure is possible, 1, 2, 3, 1, 2, 3, all are in resonance. So, they are very stable, but when we examine all 3 resonating structure, we can see that this first structure, this is having carbocation, tertiary carbocation, and the next 2 structure is secondary carbocation. This is most stable in between all the 3. In the next step, we will go for meta substitution. This electrophile Y plus will attack on the meta position. We are again getting carbocation intermediates, and on examination we will find that all the resonating structure of carbocation are secondary carbocation. Okay. Then we go for the attack on para position, and we can see that we are getting 3 resonating structure, 2 of them are secondary carbocation and 1 is tertiary carbocation. So, we know that we have to take care that 2 or 3 points. First of all, if we are going to check the stability of a carbocation, okay, then we must take in care 2 or 3 precautions. Number 1, more the resonating structure, if the number of resonating structure is more will be the stable carbocation. Okay, more stable the carbocation. Number 1. Number 2, if there is presence of tertiary carbocation in between the resonating structure, then it is more stable, then it will produce more stable carbocation, and after that it will produce more stable product or major product in the reaction. So, as you can see that after examining all the 3 possible attack on ortho, meta and para position, we can see that at ortho and para position we are getting resulting carbocation in which one resonating structure is tertiary carbocation. So, because of that the overall stability of the resulting carbocation get increased, while when we attack at meta position we are getting all the carbocation intermediate which is secondary carbocation. So, overall stability of the carbocation is much more in case of ortho and para position, while at meta position the stability is less. So, we all know that the reaction will go at that direction when the more stable carbocation is formed. Okay. So, in case of toluene means benzene with the alkyl group which is having plus I effect, the reaction will always takes place at ortho and para position. Okay. There is a written statement, if a substituent donate electron, it will enter inductively like a methyl group. For example, in toluene the substituents is attached directly to the positively charged carbon, which the substituent can stabilize by inductive electron donation. These relatively stable resonance contributors are obtained only when the incoming group is directed to the ortho and para position. Okay. Hope you can you have understand. Now, if a substituent donate electron by resonance means if the substituents which is present on the benzene ring having plus R effect, okay, it can donate the electron by the resonance. Okay. For example, we have a talk on how they can donate the electron by resonance in the last lecture. So, again we are taking the examples of plus R effect like methoxy. I have told you that the group which is having lone pair of electrons and directly attached to the benzene ring is always show the plus R effect. So, here you can see that we are taking the example of OCS3 methoxy which is directly attached to the benzene ring. Oxygen is having lone pair of electrons. So, it will show the plus R effect. Okay. So, we are taking the example of methoxybenzene, or we also know it as anisole. So, again किस पोजीशन पे सेकेंड इलेक्ट्रोफाइल जाएगा, ठीक है, कैसे चेक करेंगे? वी अगेन एग्जामाइन all the three possibility. First of all, we will see that if this electrophile Y plus will attack on ortho position, what will be the resulted carbocation and how the stability of that particular carbocation is all about. If that particular electrophile Y plus is attack on the meta position, then what is the nature of or stability of resultant carbocation intermediate? If that particular Y plus attacked on the para position, then what will be the nature and stability of the resultant carbocation intermediate. Again, so one by one let us go. So, when this attack, this Y plus attacked on the ortho position, so you can see that it will attack on the ortho position, this bond will be broken, minus plus, positive charge will be inducted on the carbon which is directly attached to the oxygen of the methoxy group. Again this positive charge will be delocalized all along the benzene ring and we are getting deregulating structure. After delocalization occurs in the benzene ring, this positive charge go to the oxygen also. Okay. This positive charge go to the oxygen also. So, there are possibilities of 4 resonating structure. When this Y plus electrophile attack on the meta position, again same phenomena occur and we are getting the resulting carbocation intermediates, but here in case of meta attack the number of total carbocation intermediates are 3. When attacks occur on the para position, again we can see that number of resonating structure are 4. So, we have already know that much the number of resonating structure, more will be the stability of carbocation and that particular stable carbocation ultimately result in the product. Okay. So, we are getting the major products of that particular relatively stable carbocation. So, you can see that when closely examining on the resulted intermediate carbocation, we can see that two things are there. Number of resonating structure in case of ortho and para position are more. So, the product after ortho and para attack of the electrophile will be major products, and number of resulting carbocations is more, number 1. Number 2 is one of the carbocation intermediates in case of ortho and para attack by the electrophile is more stable than the other. So, it will again provide the more stability to the carbocation intermediate, and ultimately we know that reaction will always goes towards that direction where we the more stable intermediates will be formed, because it will lead to the major product at the result, है ना. So, again the if a substituents which is having positive charge or partial positive charge on the atom attached to the benzene ring, they can withdraw the electron inductively, and they can withdraw the electron from benzene by resonance also. Okay. So, for all such type of substituents, the indicate resonance contributors are the least stable, because they have a positive charge on each of two adjacent atoms, as we have discussed in the previous slide. So, thus all the substituents that withdraw the electron except for the halogens which are ortho para directing, and we know that means they are ortho para directing, but they are meta directing. Okay. So, except for all the substituents that withdraw the electron, they direct the coming electrophile on the meta position except for the halogen. Okay. So, here again we can see that in case of aniline, as we told you that in the previous lecture, ammonium ions is the only group which cannot show the resonance. Okay. They can withdraw the electron by inductive effect only. Okay. So, here we can see the how the ammonium ions can affect the orientation of the benzene rings for a coming electrophile. So, here you can see that there is example of protonated aniline, and there is a second electrophile which is going to attack benzene ring Y plus. So, again there are three options. This Y plus can attack on the ortho position, this Y plus can also attack on the meta position, and this Y plus can also attack the para position. So, what happened, or what will be the major product? Okay. So, what position will be preferred by the Y plus to get the major products? So, we just check, we will carried out that attack on the all the three positions, and just check the stability of the resultant carbocation. Okay. So, first of all we goes for the ortho attack. This Y plus will attack on the ortho position. How will it attack? The electrons will coming on the ortho position. Okay. So, as the electron coming on that particular carbon, ortho carbon, this Y get attracted toward that particular carbon, and it will attack on that particular position. The positive charge will be induced on that carbon which is directly attached to the nitrogen. Okay. Now, this resultant carbocation will show the resonance, means this positive charge which is developed by the attack of the electrophile is delocalized all along the benzene ring, and because of that delocalization of the positive charge all along the benzene ring, we are getting 3 resonating structure. Okay. When we go for the meta attack by the electrophile, then we are again see that there is a production of carbocation, resultant carbocations, and because of the resonance of positive charge all along the benzene ring. So, there are possibility of 3 resonating structure also. In case of para attack, again a carbocation is formed as an intermediate, and because of the delocalization of the positive charge all along the benzene ring, there are also a possibility of 3 resonating structure of that particular resulting carbocations. So, number of resonating structure which is formed by the attack of second electrophile on the benzene are same. 3 resonating structure are possible in all of 3 orientation, ortho, meta, para. Okay. Now, you can check the stability. Now, first of all, we go for the ortho, the carbocation which is formed by the ortho position attack. So, you can see that one of the structure out of 3 resonating structure have positive charge on nitrogen as well as positive charge on the carbon which is attached to the positively charged nitrogen. So, this particular resonating structure is least stable because both the positive charge will repel each other, एक दूसरे को repel करेंगे and stability will get reduced. In case of meta position, no different things occurring, कुछ ऐसा यहाँ हो नहीं रहा, only delocalization of the positive charge occur and stability will remain so. In case of para position, we can see that the same resonance structure is also formed, which is formed in ortho substitution. So, again we are going to compare the stability of the resonating structure which is formed in ortho, meta and para position. So, on comparison we will know that the total stability or overall stability of ortho and para substitution resulted carbocation intermediate will less than the carbocation originated from the meta substitution because of the presence of a resonating structure which is having positive charge on nitrogen as well as the carbon which is directly joined with the nitrogen. Okay. So, because of that stability get reduced. So, at that condition, if ammonium ion or we can say the plus NH3 is present on the benzene ring, then substitution will reaction will takes place only on the meta position because it will shows more stable intermediate carbocation. Okay. So, now come to the next slide. Now, what happened if two substituents are present on the benzene ring and that particular disubstituted benzene ring will go for the further electrophilic attack. So, in that case, as I said earlier that resonance is more dominant than the hyperconjugation which is more dominant than reactive effects. So, if as you can see that methyl group and NO2 group, methyl and NO2 group both are present on the benzene ring. As you know that methyl group is electron donating group plus I effects, it will show the plus I effect, while NO2 will show the minus R effects, means plus I and minus R both groups are present on the benzene ring, then the stronger activator usually predominates. Okay. इसमें से जो ज़्यादा एक्टिवेटर होगा उसी के हिसाब से ओरिएंटेशन होगा. सो वी नो दैट एक्टिवेटर CH3 is activator group, it will activate the benzene ring toward the electrophilic attack, while NO2 is the deactivator group, it will deactivate the benzene ring towards the electrophilic attack. So, orientation will occur as per the methyl group. Methyl group says that the coming electrophile goes on ortho or para position. So, we are going for the nitration in the presence of HNO2 and HNO3 and HSO4. So, nitration will always occur at the ortho position to the methyl group. Okay. So, again the same concept is followed. These are the examples of different activating or ortho-para directors and deactivating, which are meta directors group. So, you can see that activating group may be of strongly activating, moderately activating and weakly activating. Deactivating groups generally they are meta directors, includes NO2 and so on. So, these are the examples, and coming to the back slides. Here are another examples where two groups are already present on the benzene ring. So, as I said earlier that if two groups are present on the benzene ring, one is activator, means out of 2, 1 can activate the benzene ring toward the electrophilic attack, and 1 is deactivator. Matlab it is deactivating the benzene ring, means it withdraw the electron from the benzene ring, and because of that it deactivate the benzene rings towards the upcoming electrophilic attack. Then the orientation will takes place as per the activator group. As again you can see there, there is example of para-nitrotoluene, means benzene having 2 groups, one is methyl group and one is nitro group. Methyl group is also present and nitro group is also present. And now you know that methyl group is a activating group. It will increase the electron density on the benzene ring. Okay. It will activate the benzene ring towards the electrophilic substitution reaction by donating the electrons by inductive mechanism. Okay. So, it will donate the electrons towards the benzene ring, total electron density on the benzene ring will get improved, and we know that the electron density on the benzene ring, electron cloud on the benzene ring will be a motivational force for the electrophile attack on the benzene ring. So, as the density of electrons and the electron cloud of the benzene ring will get increased, the coming electrophiles attract more easily towards the benzene ring. So, here is activator is CH3 is the activator of the benzene ring, while NO2 is the deactivator. They withdraw the electron from the benzene ring by minus R effect. How? I told you earlier that this is NO2. Nitrogen is the key atom. Nitrogen is the key atom and it is bonded with the oxygen, which is more electronegative than the nitrogen. So, because of that it will show minus R effect, and because of that it deactivate the benzene ring by withdrawing the electron from the benzene ring by minus R effects. As the electron density on the benzene ring will get reduced, the motivational factor will decrease for the coming electrophile and the rate of the reaction will decrease. So, one is activator group, second is the deactivator group, and in the presence of both the group, when disubstituted benzene will go for the electrophilic substitution reaction, for example nitration, then the nitration will always occur at ortho position, because methyl group is a activator and it will direct the coming nitro group on the ortho position. It is ortho paradigm. Okay. So, again steric hindrance will also play a game there, but we have to take care of that. If more bulky group is there, then ortho group will also be hindered, then it will goes to the second space available over there. So, thank you so much. I am just concluded my lecture. Thank you so much for patience listening. I hope you will understood all the things which I discussed. So, thank you. Take care. Bye.